In this video, we're going to learn how to name simple hydrocarbon compounds that have been functionalized with certain groups. Okay, so just as a quick review, we learned these base names of alkanes. We had methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Right, so these are prefixes. These are names that you need to be familiar with and comfortable with. Okay, so let's think about 6 carbon hydrocarbons. So 1, 2, 3, 4, 5, 6. Okay, so we have a 6 carbon saturated chain. This is easy to name. This is hexane. But what happens if we have other things hanging off of here? So what if we have another carbon hanging off of this third carbon? Okay, we are able to name this as well. Okay, so let's start off by recognizing that we have 1, 2, 3, 4, 5, 6 carbons. So our base structure, our parent name, is going to be hexane. What we need to do is imply that we have a single carbon hanging off of the third carbon on our chain. Okay, so since we have a single carbon hanging off, by itself a single carbon is methane, but if it's a functional group on another hydrocarbon, we call it methyl, so methyl. Okay, so having a methyl group hanging off the third carbon changes this name to 3-methyl hexane. So we have a parent chain of hexane with a methyl group at the third position, 3-methyl hexane. Alright, so let's think about how to name this compound. In this case, we have 2 possibilities for a parent chain. The possibility that seems most obvious is 1, 2, 3, 4, 5 carbons. But there's also another carbon chain here. There's 1, 2, 3, 4, 5, 6, 7. So the longest carbon chain is always the parent chain. So in this case, our parent chain is heptane. And on this heptane, we have a methyl group at position number 4. So this would be 4-methyl heptane. Okay, we can always work in reverse and make sure that 4 is the correct number. So if we were to label it from the other direction, it would be 1, 2, 3, 4, 5, 6, 7. So independent of if we start numbering from the left side or from the right side, it ends up being 4-methyl heptane. So let's try one where I give you the name and we try to come up with the structure. So if we have 3-ethyl octane, okay, this means we have an ethane group on an 8-carbon chain, and the ethane group is at the 3 position. So let's start off by writing out our octane chain. So that's 1 carbon, 2, 3, 4, 5, 6, 7, 8. Okay, this is 8 carbons long. And we want to put an ethane group on the third carbon. So this is 1, 2, 3, 4, 5, 6, 7, 8. And we want our ethane group to go on C3. And ethane, so ethyl is 2 carbons, so 1, 2. So 3-ethyl octane. Okay, the other types of functional groups that we're going to think about is if we put halogens onto carbon chains. Okay, and the naming for these is essentially identical to naming for alkyl chains. Okay, so let's think about this same parent chain. We have 1, 2, 3, 4, 5, 6, 7, 8 carbons. But on the third carbon, instead of having an ethyl group, what if it's a chlorine heteroatom? So in this case, we use the same naming convention. Position 1, 2, 3, 4, 5, 6, 7, 8. So our parent chain is octane. We have a chlorine at the third position, so we change the word chlorine to chloro. So we have 3 chlorooctane. Let's try one more. Let's draw the structure for 2 fluoroheptane. Okay, so we have a 7 carbon parent chain, so 2, 3, 4, 5, 6, 7, and we have a fluorine at the second position, 2 fluoroheptane. So naming these is pretty straightforward. The things you need to be the most careful about is making sure that you're naming it such that the number of the modification is as small as possible. And also, like we saw up here, you want to make sure that you're always selecting the longest carbon chain to be the name of the parent chain. So this is a heptane chain, not pentane.